Hello everyone, it's Noe here and welcome to this video where I will teach you how to make a 3D object look instinctively at the mouse position in the GODOT engine. But this method is applicable anywhere. The goal here is to get something that looks like this, where a player object is looking where my mouse is pointing. But first of all, I will explain you the used method with pretty animations that I handcrafted with love.
Let's imagine a simple 3D scene with some objects in it. Here we have a sphere and a cube. Next, we will represent the view frustum of our camera, which looks something like this. Now let's take a closer look at the camera. We can see its origin represented by the purple dot and the viewport over there with the two objects displayed on it. This is what will be seen on screen. Now let's say I click the side of the sphere on the viewport and I want to know where that point originally is in the 3D space. What I can do is to cast a ray from the origin, passing through the clicked point. Then, when the ray continues, it hits the sphere at some position, and that position in 3D is what we were looking for. The same can be applied to any position as long as the ray hits a physical object at the end. If you click empty space like the sky, it will not work, because the ray will never hit something.
So back in GODOT, you want to make sure you have a ground plane. So here I have a static body with a mesh instance and a collision shape. Then I have a player scene, and here I have just a simple mesh instance. Make sure your mesh or object is facing towards the negative z-axis, and then of course I have a camera, and the view looks like this. In your player script you want to set up a few variables. So I have a onReady variable which gets essentially the camera node, so I have a reference for later. Then I have a variable called ray origin, which will be a vector free, and another which is ray end, which is also vector free. Next, in the physics process function, we want to define a new variable called spaceState, and we set it to getWorld.directSpaceState. Basically, we get the current physics state of the world. Next, we create a new variable called mousePosition, and we set it to getViewport.getMousePosition. Basically, it's the mouse position on the screen, or the viewport. Next, we set the ray origin variable to camera.projectRayOrigin of mouse position. So basically on the camera we get the origin of the ray, so it's the same as the origin of the camera as I showed you on the animation. Next, we set the ray end variable to the ray origin, so we go back to the camera origin and we add another vector to that. That vector is camera.projectRayNormal of mouse position. So basically this gives us a direction vector for the ray according to where you clicked. So that's a normalized vector, so we want to multiply it by some high number, so it's actually like a long ray. And when we add this to the ray origin, we get the ray end. If you don't quite understand that, ask me down in the comments. So anyways, next we define a new variable called intersection, and we set it to spaceState, so spaceState that we defined previously, and .intersectRay. So this is a cool function on the physics state object that is basically a ray casting function. So we cast the ray from the ray origin to the ray end, and this whole thing returns a dictionary with some info about the intersection or the hit. So if you click the sky, for example, the ray will not hit anything, so the dictionary will be empty. So if it's not empty, so we hit something, we want to set the var pos to intersection.position, so we get the position of the hit. Next, we want the player, or the representation of the player, to look at that position. So I get my rig, which is my representation, and I use the function lookAt. and I look at a vector 3 of all the axes of the intersection position. Well, if I do that, look what happens. My player, or the object, looks directly at the mouse position, or where the ray hit the ground. I don't want that. I want the player to look parallel to the ground. So instead of pos y here, I set it to my own translation y, so my own y-axis, and this fixes the issue. Hooray! Anyways, the last argument to the lookat function is a vector pointing upwards. So here in my game, pointing upwards means 1 on the y-axis. Noe from the future here, I want to explain you why we want the object to be facing towards the -z direction. Basically, the lookat function that we are using rotates the object so that the local -z axis points towards the target position. So that's why. So this is the end. I hope I helped you, and if you have any questions, ask them in the comments and I will try to reply. And see you in the next video.